QED. In the next half hour, QED takes you behind the normally closed doors of the world of the testers. You will see the bus into a solid concrete wall at 30 miles per hour test, the can it take off while scraping along the runway test, and tests on the dangers of exploding custard powder.
5, 4, 3, 2, 1.
The testers have already had their go at virtually everything we see around us. Take this petrol tanker, for instance. It's a new design. It's made of plastic. The authorities were worried about its strength. Would it crack if it turned over? Well, there was only one way to find out. The prototype was taken to the Transport and Road Research Laboratory for the test. It's now under radio control, and the plan is to drive it round and round, faster and faster. Let's skip the first few circuits and pick it up as it goes into the fourth. And the fifth. Now the sixth. The tanks held. The only thing that failed was a lid, and that's since been redesigned. The engineers had calculated the tanker would be all right, but the test was to make sure. And whilst the prototype was there, they did another test, just to see how the plastic body would stand up to it. It did. The tanker is now in service. Now testers and the tonic water bottle. It's the power of the fizz that concerns them. Most of us know about pressure from car tires, 26 pounds per square inch. But how does this pressure compare with the fizz of tonic? Every day in a glass factory in Doncaster, the testers prepare bottles to check that even after you've given it a good shake, the glass is still strong enough. 100, 200, 300. 320 pounds per square inch. I bet that surprised you. Now a beer bottle. 315. 200 is the pass mark. Below that, and the whole batch will be destroyed. Now, how about this familiar shaped bottle? 200, 400, 600. 720 pounds per square inch. And yet the fizz will only be about 50. A slight case of over-design? This equipment is for use in a food factory. Testers from the Health and Safety Executive are seeing how it stands up to dust explosions. Almost anything that burns, if it's in a fine enough powder and being blown about enough, can explode. And that includes custard powder. But outside the goons, who's ever heard of exploding custard powder? QED reveals all. Take 4 grams of ordinary custard powder. Now tip it into a saucer. Place a glass tube directly above it. Stick into the tube a small coil, rather like a car cigarette lighter. When it gets red hot, be ready to blow the custard powder past it.
2, 1.
It works every time. But there's nothing magic about custard powder. Icing sugar can go the same way. And this shows the power of the real thing, an explosion in Britain's #1 custard powder factory. In Banbury, Oxfordshire, November 1981, 8 workers were seriously burned. But back to the testers. On the Derbyshire moors is the Health and Safety Executive's Test Centre for Explosions. That was an oil drum of acetone. It's used in nail varnish remover. And it's here they test bottled gas containers. The valve has to be foolproof. This test demands cooking the cylinder. As the container gets hotter, the pressure inside builds up. That jet shows that the safety valve is working, releasing a controlled amount of gas. And if the valve wasn't fitted? They also test fireworks. New ones from abroad, this one's Chinese, have to be checked out before they can be imported. The dummy is to give some sense of scale. And now in slow motion. Any firework that went like this would be refused an import license. From their long experience, the testers over the years have learned that you can't be too careful when getting ready to test explosives. Every part of the body must be protected. Eyes against flying debris, ears against the deafening bang. It's not the guns they're testing, it's the caps. The health and safety people test samples of all imported caps before they are allowed in. That includes the inadvertently hit while in your pocket test. This is to make sure there's no risk of the whole pack exploding. Failed. Import license refused. In Berkhamsted, deep in the home counties, the testers need flies. 100,000 houseflies a week, every week, winter and summer. These are the pupae. They are being measured out into net cages, about 150 a time. They are reared in perfect conditions, exactly the right temperature, the right humidity, and the right food, a constant supply of milk and water. After a week in the breeding room, they are ready. Every half hour for 3 days a week, in a clinically clean, windowless test room, a tester gives a carefully timed squirt of fly killer. Two nets of flies are released, about 300 in all. Fly killer has two main ingredients, one to knock down the fly and the other to actually kill it. It's a quick knockdown that's vital. That's what sells the stuff. After 2 minutes, the testers count the number of flies on the floor. They are monitoring that knockdown effect. They will do it again at 4 and 6 minutes. Usually, by the 8-minute count, it's easier to note the ones still flying. At 10 minutes, the test is over. Now the collection. All the flies, whether they be fit, knocked down or dead, are sucked into jam jars. And now they're off to the recovery room. The survivors, if there are any, are in for the time of their life. They are given as much sugar and water as they can eat. This is to make sure that if any are going to live, they do in fact thrive. 24 hours later, the jars are examined. all the dead flies are taken out and sexed. After all, they aim for equality. If you are wondering how, well, if it's white underneath, it's a female. Then they are counted. Out of the original 300 or so, if more than one fly is still alive, the fly killer has not passed the standard test. And what happens to the fly that's still alive? Oh, he's chloroformed. This is a flagellator in Luton, cleaning a carpet. The design of some tests has called for sheer creative inspiration. Next, a container of, well, you'll never guess what. A clue. What is it that must be imported from Sweden, although you can find plenty in your own home? It's dust. International standard dust, produced to a rigid specification. Next, a variation on a garden roller. Precisely 33 pounds of solid steel, rolling the dust in at precisely 1 meter every 45 seconds. Twice all over, and then, at 3 times that speed, 28 more times. And the test? It's for vacuum cleaners, and precisely the same test is used throughout the world. The rest is easy. It's just a case of weighing the bag to see how much of that dust was picked up. Having beaten the dust barrier, now the testers are developing international standard dog hair. This is a test to see how good the seat is. And the bumps, they are carefully designed slats of wood developed by the National Institute of Agricultural Engineering in Bedfordshire. Researchers from Nottingham saw that test and applied it to bikes. Weights represent the rider. Here, it's a bike designed for a 6-year-old, but being tested with the weight of a 12-year-old. Officially, to pass the test, the bike has to stand 100 hours of this. Privately, they expect nothing to break for at least 500. And this is a French variation. It's the try and puncture the tire test. They are supposed to represent the sort of obstacles you find working in a forest. And this is what testers in Leyland in Lancashire consider a bumpy track. Now it's the trying to break the suspension test. It might look as if it's on a building site, but every bump, every ridge has been carefully planned. And how hard is it on the drivers? Well, they're only allowed to do 10 laps at a time. But now it's possible to take the bumpy road test a stage further and get rid of the road and the driver altogether. This lorry has a mass of instruments connected to each wheel. Every bump, every jolt is being faithfully recorded. The testers are gradually building up a whole library of different roads. Back at the research centre, they're on a typical main road somewhere in Britain. Hydraulic jacks under each wheel reproduce perfectly every bump and vibration. Now for a really rough road. It's just a case of changing the magnetically stored data. This is a road in the Middle East. It's across the desert in Oman. And it's all happening quite faithfully in Lancashire. Efficient it may be, but it's not half as much fun as this. Miners are wound up and down the mine shaft in what are called cages. In 1973, there was a tragic accident at Markham Colliery in Derbyshire. The winding mechanism failed and a cage dropped to the bottom, killing 18 miners. The problem, and it's common to most crashes, whether it be lifts or cars, is how to make the impact more survivable. One idea they came up with can be demonstrated with a soft drink can. One end has been cut off, otherwise it's absolutely standard. Two of these cans are placed at the bottom of the model shaft. The speed at impact was exactly the same, but instead of stopping instantly, the progressive squashing of the can slowed the cage gradually, and that was enough. Now for a full-size test. The cone is to stop it filling with coal dust. This will be the equivalent of a heavy lift dropping 3 meters a second.
5, 4, 3, 2, 1, fire.
It happens very fast, but with slow motion, you can see the way it crinkles is exactly the same way as the drinks can. That principle of slow crushability is now being applied in, of all places, a children's playground. Here, the problem is the ground. If it's hard and you fall head first, you don't have to drop very far to kill yourself. So what's the best surface to play on? Greater London Council scientists have developed a machine for testing just that. This object is the weight of a 7-year-old boy's head. He's going to be dropped head first, as it were, from different heights. It's wired up so the testers can analyze the impact. Deaths are not usually from broken bones, but from the brains splattering against the inside of your skull. This is about 10 inches above bitumen. The testers look at the steepness of the trace. Surprisingly, that 10-inch drop would have killed, and concrete would have been about the same. The question is, can safer surfaces be developed? The testers now take the weight to the height of a swing, about 5 feet. And the trace is less steep. A child would have survived that drop. Now a thicker artificial surface. They take the weight right to the top, about the height of a slide. Smoother still, survivable even falling 9 feet head first. But can these surfaces stand up to the wear and tear of children? In Lambeth, a patchwork is being given the ultimate test. Incidentally, QED was curious as to how safe grass is. Almost as good as the best artificial surface, but that's after a wet winter. In a dry summer, they found grass had the same killer rating as concrete. This is the bike into a curb at 12 miles per hour test. The testers don't like this, though. It's too variable. The bike doesn't always fall the same way, for instance. Under more controllable conditions, the same 12-mile-an-hour test. The pendulum is the equivalent of the curb, and it's easy to measure the breaking point. "30 miles per hour, and there's not much left." Staying on the theme of how tests evolve, this is research film of various designs for safety cabs. The water in the tires is only for ballast. they had that same problem of quantifying the results. No two tests were identical. They then devised a standard test, an incline with water flowing over the side to simulate a slippery slope. That worked better, but they were still writing off a tractor on each test. And this is how it's done now. The white polystyrene is the space the driver will take up.
After 5, 5, 4, 3, 2, 1.
It passed. The driver will be okay, and so is the tractor. Aircraft, though, have to be treated more gently. Or do they? This is called the minimum on-stick test. It's to see what happens if a pilot lifts the nose up too high, too soon, and scrapes the runway. Will the aircraft still be able to get enough lift on the wings to actually get airborne? It's a standard test. All new designs of aircraft are put through it. And this aircraft is being prepared for the flutter test. Mini wings are fitted to each wingtip. Have a guess what they're for. They're to induce bad vibrations, the sort that it's just possible could occur in freak conditions. The testers have to make sure there's no risk of the aircraft shaking itself to bits. Then there's the stall test. The aircraft deliberately flies so slowly that it loses lift. And now the pilot is climbing back to have another go. Not that everything always goes right, as this hurriedly shot film shows during a sudden braking test. This is another sudden braking test. The problem is that so much heat is generated by the brakes, there's a real danger of the tires literally blowing up. The solution is for the tires to automatically let themselves down. But some of the most dramatic aircraft tests are done by NASA. They swing real aircraft into the ground. This way they can simulate actual crashes. They are trying to improve the crash worthiness by recording exactly what happens. So far, they've had 25 successful crashes. But how about this for a crash test? It's from the archives of the Transport and Road Research Laboratory. The bushes are Rosa multiflora. They'd hoped they could be used as a crash barrier. A pretty idea, but no, thank you. Then they tried a concrete curb. Again, no thanks. A higher curb. A wire barrier. Looks good, but now from a sharper angle. wire caught in the front wheel. How does it cope with a lorry? Back to the drawing board. They still persevered with their wire. This was on the M4 just before it was opened. It stretched too much. And how does the familiar design perform? No crossing the central reservation, no deflection into other lanes. And from America, a crushable system for Y-junctions using bins full of sand. Or plastic cells full of water. Nowadays, the impact testing of vehicles has been developed into a fine art. And now at last, what you've all been waiting for, our bus. Tests like this are over in a fraction of a second, so the tester's maxim is film it from every angle and preferably in slow motion. Incidentally, that test proved it's the strongest bus in this country by far. And after all that destruction, a pointer to the future. A test on a new plastic bumper. Finally, see if you can figure out what this test is all about. A clue. It's testing for the opposite of everything you've seen so far. Get it? Well, golf is controlled by the Royal and Ancient Golf Club of St Andrews, and for some years now they've been insisting that samples of balls are tested to make sure that they're not too good, that they won't go too far. Without the test, either golf would become easier or all the courses would need extending. And what happens to the balls that are just within the limit? Ah, they're kept for the manufacturer's star players. Who said testing's always for our benefit?